Okay. So let's just kind of look over some updates that I made to the site. So first things first, the remaining book assignments are posted. Now the Rebel ones aren't up. I need to do that. The Rebel ones are in Rebel, so they've been going along for the last two sections of what's called Chapter 13. The matching chapter in Zybooks is Chapter 7. And again, just because the fact that I can set these iBook dates to the end of the semester, or a couple of days before the end of the semester, and anytime you turn it in before then is good, that helps. So you're welcome to do either one, but it's probably easier to do uh, the Rebel ones, or so the Zybooks ones. So for this last chapter, we're going to be getting into C++ classes and objects. And this is something I'd like to do earlier in a class, but you sort of have to lay a lot of groundwork. If you take another semester of C++, which I hope you will, either here or somewhere else, you're going to find that there's a lot of focus on classes and objects. And C++ is known as an object-oriented language. A lot of languages are object-oriented. Most of the common ones aren't. What that means is when we model something, we want to model the whole thing. We don't want to have all these different variables laying around. And one of the things we ran into before, like when we were making the game, and we said, well, I want to be able to call these functions, but hey, this one function needs to know if they picked up a key in this other function. How do I get this data from place to place? Well, the way that would make sense is to have objects that hold the data, and then you pass those around. So just as a housekeeping thing, I'll indicate if you are going to do the last assignments. I hope you will, but I mean, the last ones that are there, they're a little larger, and so what I'm indicating is they kind of count double. So if you have two other chapters that were lower than what you score on the next sections, the classes and objects chapters, then I'll replace those grades with those. So it's a pretty good way to boost it. Especially if you do the Zybooks, the way Zybooks is set up for this semester anyway, you can sort of retry questions until you get them right. And I'm okay with that. The important thing here is getting you guys the basics of the language. You'll probably go on to do more. And so it's most important to me that you have that understanding. And if you follow that link, it'll take you into the Zybooks. I also posted that you can get to all the videos in the YouTube playlist. So today's video will be uploaded in the same place. So now I want to go into the assignments and we'll look at the new module available, Module 5. Pretty sparse right now. I'm going to put the links for the slides, things like that. And we have this one assignment. This is what we're going to work on this week. And I'm going to pretty much walk you through it. So I want to go through the Zybooks lecture, sort of to see what people think of it as far as how it explains the idea. And we're going to write a simple program using a class and talk about what that means and why you would do it. And then that'll be due in a week. All right. I'm going to go into sort of a blank REPL-it to look at this. And let's say, what if I were going to make, let's just say, in theory, what about a program? I wanted to make, let's say I want to make a game, and it's going to be like a car racing game. Now, back in the day when I was coming up in like the late 70s, early 80s, there were a lot of video games. You're like, oh, wow, you can go to space, or you can drive a car, or you can go to the jungle, and they were all text. So, you could kind of be as imaginative as you wanted to because you were just reading words or looking at little dots on the screen. So that's something you could still do. And later on when people add fancy 3D graphics, that just kind of goes on top of the existing code. So let's think about what if I wanted a situation where I needed a car racing variables. Okay, so let's say I'm going to have something like int weight, int horsepower, top speed. There's and many more. Maybe a turning radius, all kinds of stuff. So if I want to model, a car in like a video game, I got to know a lot of stuff about it. Some cars are faster, some cars weigh more. Maybe a more expensive car has to be in a certain class than others. So you might have a lot of variables. The problem is this is just for one car. So do I do something like weight of second car this gets messy. Because the thing is, I could see just having all these variables for one car. But what if I want to have a dozen cars, or even just two? How am I going to handle this? And so this is when we want to move into what's called object-oriented programming. And the idea behind this is pretty straightforward. We have a thing called a class, which is like the Platonic ideal, the idea of a car. What would a car have? A car would have some weight, it would have horsepower, top speed. Okay, now I want to have my car. My car weighs this much, it has this much horsepower. So you're filling in exact values for all the sort of general stuff. So the idea is like, if I say class would be car, and an object is an instance of that class. It's one unique real thing that is of the type of the class. So my car is an object of type car. Your car is an object of type car. So I'm going to go into the chapter as it kind of explains it, and we'll take a look at this. Sorry, my scroll is going crazy here. All right. Good. So see if I can zoom this in a little bit. Not so much. All right. So again, I recommend that you check out the zyBooks or the Rebel one. I'm going to use the zyBooks one here. It's a little easier to present. The slides for chapter 13 are pretty much the same kind of material. So here they've got a picture of a living room. I've got a chair. Okay, well, what could you do with a chair? You could sit on it. Okay, well, what are things we know about that chair? It's green. It's made of wood. Okay, how about a couch? Well, a couch is kind of similar to a chair, but you could also lie down. You can't really lie down comfortably on a chair. So on the couch, I could sit and lie down, and it's made out of wood, and it's got red fabric. And I've got all types of things here. So the idea here is kind of like I talked about having multiple cars. I could have multiple pieces of furniture, and those different pieces of furniture have different things you can do. So you can think about, we know about variables, and we know about functions or methods. When you think of those in terms of a class or an object, because I'll kind of use those interchangeably. Like I said, dog is a class. My dog is an object of that type of class. Human is a class. You are a object of type human. They're going to have state and behavior, and that's just a fancy way of saying that classes have variables that describe what they're like, and they have methods or functions that describe what they can do. All right. And here, I'm not going to run through the animation, but you can kind of see, well, if I had a restaurant, what could I do? Well, I could say what name the restaurant is, what the phone number is. Like, go look at Yelp. For any restaurant, it's got a name, it's got a phone number, people reviewed it, and it's got different types of food they have. And I would be able to, have functions to do those things. So state and behavior. An example a lot of people like to use when they teach this stuff is like a dog. Like, okay, a dog is type dog, and my dog can bark, and maybe a different size dog has a louder bark. I don't think that's super useful, and the reason I say that is when we're talking about objects and classes, we're talking about what's called here an abstraction. And what I mean is, like, if I have an object that is a student, I'm not trying to model, okay, what do you like to do when you relax? What color is your hair and your eyes? I'm modeling the things about you that I need to know from my program. Okay, so in WebAdvisor, what do I need to know about you? I need to know your name, your student ID, what classes are you taking, what's your GPA, all that good stuff. So when you talk about an object or a class, you're talking about a thing, in a program. So when I talk about a car having speed and all that, and top, weight and horsepower, that's because in the game I would be making, different cars would behave differently. They would have different handling. So I don't try to model everything about an object. You're not trying to create the whole thing as a full simulation. You're taking the data you care about and you're modeling it. Okay. And one of the other things about abstraction is, like, when I drive a car, in a game, I use the joystick or controls or whatever, and I steer left and right. I press the gas. I'm not thinking about, I have to pump in extra fuel so the engine goes faster, all that stuff. Think about the abstraction of a real world object. In a car, you turn the wheel, you press the pedals. A lot of things go on underneath the hood, literally, that you don't care about because they just happen. And that's abstraction. I'd write a function called step on the gas, and the car would go, accelerate and it would go faster. And I wouldn't have to worry about all those details. Now, when I say I wouldn't have to worry about those details, well, whoever writes the class would have to figure out how to make it work. You know, the person who builds the car has to understand, but the person who drives the car doesn't. And it's kind of like how we've used C in, C out, and they do some nice stuff. And occasionally we found other methods out there we wanted to use to make things work well. And we kind of just said, well, these work. That's nice. I won't worry about how they work. And that's the whole reason you use an object-oriented language is you have complicated things with sort of simple interfaces. You think about your TV. It's got a couple of buttons on it. Turn it off, change channels, change inputs. A lot's going on inside that you don't have to worry about. And that also has to do with information hiding, which is, you know, I don't need to know what hertz the electricity coming into my TV is or how to turn on a pixel. It just happens. And so these are just some terminology they're throwing out here. When you see people talk about ADT, they're talking about an abstract data type. So if I have a type of data that I can do a certain thing with, like let's say I have a list, what can I do with a list? Just sort of the idea in general of a list. I could add things to a list. I'm going to write things on my list. I could take things off the list. I could change the order they're in. So a list is one abstract data type. Sometimes these are called collections. But an abstract data type could be sort of any data. You know, if I'm modeling a car or a piece of furniture or an animal, and I want to keep track of information. They have a silly little picture here just saying, you know, when you're using the stove, you don't leave it open. You know, if you're cooking something, you set it to cook and you don't need to know the details. All right, that's just kind of to be goofy. Let's go into actually looking at what it looks like to have a class, okay? So in this example, we're looking at a restaurant. Let's see if I can zoom this out a little more. Okay, that's not doing it for the screen. Give me 1 second here. Okay, sorry, never mind. I'm just fiddling with my controls here. Let's see if I can make this a little easier to read. No, that's okay. I'll just tell you what's going on here. I'm going to put this code into a Replit with nice big windows so you can see it a little bit better. Okay, good. There we go. Now that's looking a lot more like it. Sorry. Okay. Nope, that's not helping. I apologize for my fiddling here. All right. I've got a restaurant, and so this is how you set this up. So you say class restaurant, and inside of it I have a few functions or methods. So I'm going to take this code, and I'm just going to put it in Replit so you can see it a little better. I'll put it up here above main for reasons that I'll show you later. Okay, good. That's a lot more readable here. Right, so, okay. All right, so I've got this class, and you see here it's got curly braces, a lot like a kind of like a function does. You know, so when you declare a class, you're saying here, okay, within these curly braces after a class and the name of the class, here's some stuff about the class. All right. What's this public mean? Okay. If I'm using the object, here's information that I want to be exposed. We talked about how, you know, you've got information hiding. You don't hide all your information, you just hide the internals. So if I look at, let's take restaurant, what I could do in Yelp, how would that work?